Thinking Like a Programmer, Part 1, Foundations of Computational Thinking. Chapter 1, The Programmer's Mindset. Programming is more than just writing code. It is a way of thinking about problems and solutions. The programmer's mindset involves breaking problems into smaller, manageable parts, embracing trial and error as a method for discovery, and thinking logically and systematically. These principles form the foundation of computational thinking and are essential for tackling challenges both in programming and in everyday life. Breaking problems into smaller, manageable parts. One of the first skills a programmer learns is how to decompose a problem into smaller components. This process, often called problem decomposition, is critical because it makes complex tasks less daunting. For instance, consider the challenge of organizing a large event. Instead of viewing it as one overwhelming task, you can break it down into smaller steps, choosing a venue, sending invitations, arranging catering, and planning activities. Tackling each piece separately reduces stress and ensures nothing is overlooked. Programmers apply this same principle when writing software. A large program is divided into modules or functions, each responsible for a specific task. By addressing one module at a time, they build solutions piece by piece. This approach not only makes the process manageable, but also allows for flexibility and focus on individual components. Embracing trial and error, the power of iteration. Trial and error is an inherent part of problem solving, and programmers understand this better than most. Rarely does a piece of code work perfectly on the first attempt. Debugging, testing, and refining are integral to the process. Iteration, the act of revising and improving, allows programmers to learn from mistakes and create better solutions over time. This principle is equally relevant outside of programming. Consider learning to bake a new type of bread. The first attempt might yield less than perfect results, but each subsequent try allows for adjustments, perhaps tweaking the temperature, proofing time, or ingredient ratios. Iteration is not failure, it is progress in disguise. Embracing this mindset fosters resilience and a willingness to explore creative solutions. Thinking logically and systematically. Logical thinking is at the heart of computational thinking. Programmers rely on clear step-by-step reasoning to design solutions and anticipate potential issues. This systematic approach minimizes errors and ensures solutions are efficient and effective. In everyday life, thinking logically can help with decisions as simple as planning a route to work. By systematically comparing options, factoring in distance, traffic, and time constraints, you can determine the best choice. Logical thinking is a skill that improves with practice, making it easier to navigate complex situations with confidence. Chapter 2, Algorithms in Everyday Life. What is an algorithm and why does it matter? An algorithm is a sequence of steps designed to accomplish a specific task. In programming, algorithms are the building blocks of functionality. But algorithms are not limited to the digital world. They are everywhere. From following a recipe to assembling furniture, we use algorithms daily, often without realizing it. Understanding algorithms allows us to approach tasks more methodically. For example, following a recipe involves a series of precise steps, measuring ingredients, mixing them in a specific order, and cooking for a designated time. Skipping steps or altering the sequence can lead to unintended results. Recognizing this process as an algorithm helps us appreciate the importance of structure and order. Real-world examples, recipes, driving directions, and decision making. Recipes are a straightforward example of algorithms in action, but driving directions are another. Navigation apps use algorithms to calculate the fastest or most efficient route to a destination, considering variables like traffic and road conditions. By following these step-by-step instructions, we reach our goals efficiently. Algorithms also play a role in decision making. Imagine deciding where to eat. You might consider factors such as proximity, price, and reviews, applying a step-by-step process to narrow down your options. This systematic approach mirrors how computers process data to reach conclusions. Chapter 3, Abstraction. Seeing the forest, not just the trees. Abstraction is at the heart of focusing on the essential details while ignoring the irrelevant ones. It is a cornerstone of computational thinking, allowing us to simplify complexity and solve problems more effectively. Simplifying complexity by focusing on the essentials. A map is a perfect example of abstraction. It doesn't depict every tree or building. Instead, it highlights the critical features necessary for navigation. Similarly, when summarizing a book, we focus on key themes and events rather than recounting every detail. Abstraction helps us process information efficiently and prioritize what truly matters. Real-world abstraction, using maps, categories, and summaries. In everyday life, abstraction is invaluable. When categorizing expenses, for instance, grouping them into broad categories like food, transportation, and entertainment simplifies budgeting. Summarizing meeting notes into actionable points ensures clarity and focus. Abstraction enables us to handle complexity without being overwhelmed. Chapter 4: Patterns and Reuse. Recognizing and leveraging patterns to solve new problems. Patterns are recurring elements that simplify problem solving. Programmers often encounter similar challenges across projects and develop reusable solutions, known as design patterns. By recognizing these patterns, they save time and effort. In life, recognizing patterns is equally powerful. For instance, if you've successfully negotiated a discount in one situation, you can apply similar tactics in the future. Patterns provide a framework for approaching new challenges with confidence. Examples from life: reusing solutions in similar situations. Think about packing for a trip. If you've developed a checklist for a weekend getaway, you can adapt it for a longer vacation by adding or removing items. This reuse of a proven solution streamlines preparation. Similarly, troubleshooting a recurring issue with a household appliance often involves identifying a familiar pattern and applying a known fix. Recognizing and reusing patterns helps us navigate life more efficiently. By building on past successes, we create a toolkit of strategies that make solving new problems less daunting. Through these foundational concepts, computational thinking offers a practical and powerful way to approach challenges in programming and beyond. The journey into this mindset begins with understanding these principles and recognizing their relevance in everyday life.